Hi, my name is Evan Mueller.
And my name is Taylor Markl.
Today, we will be presenting the difference between machining with cutting fluid versus dry, high-speed cutting, and the pros and cons of both, as well as manufacturing readiness assessment of the dry cutting process. Firstly, we will discuss machining with cutting fluids. This works by flooding the cutting surface with a fluid either internally through the tool or externally through hoses. Benefits of using cutting fluid allow for greater depth of cut, keeps tool cool, and from experiencing excessive heat. Better surface finish and tighter tolerances as well.
To elaborate, the importance of coolant is that it removes heat by both reducing friction and eliminating part heat. Thus, there is no thermal expansion of the piece, allowing tight tolerances to be reached. Without friction, the passes can be much cleaner and provide a good surface finish. Chips can also be flushed out. This removes vibrations and hot spots, which may damage the integrity of the piece through continued machining. Under the circumstances, tool life is also greatly increased.
For a company, it can be easy to get coolant, as it is quite easy to purchase online. However, there are different types of coolant that vary by cost and properties, some better than others. However, the cost of coolant is usually 7 to 17% of the total cost to make a part. This is more than the tooling cost, which can vary from 4 to 7% of the total cost of the part. The cost can range from $19 to $206 depending on the coolant and quantity purchased at once. The cheapest oils are soluble oils. Most coolants need to be properly disposed of and can't just be thrown out. This is the most expensive part of the coolant outside of the cost of the equipment to use coolant.
While coolant is beneficial to part finish and tool life, it is also dangerous. If coolant is not at the right concentration, there can be risk of less heat transfer and increased corrosion. High concentration also reduces lubrication, which removes the clean surface finish desired. Lower concentration corrodes the workpiece and can also reduce tool life. Aside from machining downsides, coolant is also dangerous to the environment. Coolant leaks are harmful to both the environment if exposed to large bodies of water and people's skin or lungs.
The other type of cutting procedure is dry, high-speed machining. It is used only for facing, cutting, and side milling procedures, and not used for drilling, threading, and turning procedures. The reason dry cutting is not used for these procedures is because the tool experiences too hot of temperature as well as chips getting stuck. The reason for this is because there is no way for the chips to escape easily from the cut. The heat generated is also so great it can cause material and tool deformation. Instead of flooding the tool with coolant, carbide tools are used that are strong and cut material without needing coolant. The carbide tools are generally coated, sintered, or polished to create a shield against heat. Minimum quantity lubrication or compressed air are used to clear chips from the cutting area as well. The advantages of dry cutting are avoiding thermal shock, which reduces tensile stress and high temperature changes. Thermal shock occurs when the part is cutting against the material surface and then is quickly cooled through something like a coolant. By avoiding thermal shock, this helps keeps the tool from wearing and breaking. Dry cutting also runs extremely fast and is faster running a large number of small depths of cuts than wet cutting when ran at higher depths of cut.
The two processes have both advantages and disadvantages for different scenarios. It is important to note that a business or manufacturer's overall goals dictate the better suited process. Cutting with coolant is overall more versatile as it can be used for any process. Expenses can be shifted towards providing coolant instead of buying more expensive carbide tools. Tighter tooling tolerances can also be achieved since thermal expansion has no chance to play a role with coolant. However, the tool will experience constant thermal shock when performing an operation like milling. While coolant may increase tool life since there is virtually no friction, it can decrease tool life from repeated thermal shock. Dry cutting provides a much rougher surface finish since it is exposed to the effects of friction. However, aside from buying the carbide tools, there are no excess costs. The said carbide tools are also cost effective since their tool life is much longer because of their quote-unquote heat shield. Dry cutting can also be run at extremely fast speeds because of the carbide technology. Compressed air can be used in place of coolant to remove excess chip buildup. It is also overall better for the environment and workers' health.
Dry cutting is superior to wet cutting when parts will be post-processed, meaning final surface roughness doesn't matter, only final dimensional tolerances. The surface roughness can be cut down later. Dry cutting offers a substantial decrease in both operating cost and production costs, as there is less machining time and no coolant flow. It has been observed in a laboratory environment that dry cutting tools sees 2.5 times the tool life of wet cutting.
Since high-speed dry machining is a newer process compared to conventional machining with fluids, it does not score a perfect score under the Manufacturing Readiness Scale. The Manufacturing Readiness Scale provides an understanding of the relative maturity and associated risks with the dry cutting process. Dry cutting is a process that has been taken up and researched heavily since its debut. Thus, the process has been implemented into low production part manufacturing. For manufacturers that do not have to worry about wet machining or complicated parts, dry machining has been implemented to obtain the luxury of outputting pieces at faster rates. All parties understand the risks and trade-offs with dry machining. However, since the process is fairly new and has yet to prove its behavior in future results, it gains a score of 8. Dry cutting has no solution towards high volume or complicated parts as of yet. The carbide tool eventually will also see a decrease in coating wear from constant application processes. It cannot be scored within the 9 or 10 range because there is no 3 or 6 sigma quality control created that goes over the quality of this machining process.
Our first source, The Importance of Coolants in Machining, describes the purpose of using coolant, the different types and how coolant works, and what coolant concentration is. The article sticks to its topic and information without self-advertising. However, this website does sell coolant, and for this reason, the overall bias is low.
The second source, The Role of Coolant in Tool Longevity and Cutting Performance, provides the benefits and uses of coolant on machining processes, as well as the different kinds of coolant's uses. There is no scientific backing to any of their claims, and they insert a self-advertisement towards their machining products at the end of the article. Thus, the source can be named moderately biased.
Our third source, The Benefits of Dry Machining, goes into the reasons one would want to use dry machining, current applications of dry machining, and the benefits of dry machining, quoting people with first-hand experience, as well also aware of the argument of using coolant and disputes the two options. For this reason, the bias is very low.
The final source, How It Works, Dry and Near Dry Machining, analyzes the evolution of dry machining. It also branches out into mentioning that coolant can still be useful at low quantities rather than high. The two processes are compared and contrasted without a specific lean towards one another. It can also be stated that the bias for this resource is low. Here is the slide that depicts the resources we used during our research. Thank you for listening.